All right, y'all. Here's a little bit of homework help on pages 205 and 206 in your Think Up Math book. This is on Pythagorean square models. Sorry I missed class today. I was not feeling very well, but I should be back tomorrow. All right, so first thing, in my 5th period class, I made some little anecdotal notes on what you should be paying close attention to as you work through this assignment to answer the questions accurately. This is due in Skyward, by the way, by Friday, February 11th by 11:59 p.m. So question number 1 on page 205, it says, look at the figure. And remember, the hypotenuse is the longest side. And that is my c squared, or c and c squared, okay? So I need to find the side that's the longest. So obviously it wouldn't be n, and it's also the side that's opposite from the right angle. So if I can draw an arrow from the right angle and point to a side opposing it, that would be my hypotenuse, okay? So my hypotenuse here is 289 squared. That's the area of this square. The area of this square down here is 225, and we need to find n. So in order to find n, I have to work my Pythagorean theorem backwards, okay? So in our notes, we should have written that if Pythagorean theorem states that a squared plus b squared equals c squared, then if I'm working backwards to find b squared or to find a squared, then I must subtract a squared and b squared from c squared to find the other. So yes, please jot this down in your notes to keep that in mind. In order to find a missing side, I subtract the known side squared from the hypotenuse squared. All right, so here I'm going to take 289 and I'm going to subtract 225. So down here, 289 minus 225, and then I'll subtract. 9 minus 5 is 4, 8 minus 2 is 6, and then 2 minus 2 is 0. So then I would square root this 64, square root of 64, and that would be my answer. But of course it's going to be in, what's my answer? Of course it would be in the side square form. Okay, I'm not going to tell you what this is. And then boom, this. Based on the Pythagorean theorem, which of the following is not true? We should have just written this down in our notes. A squared plus b squared equals c squared. And addition is commutative, so if I switch it, then it's also b squared plus c squared. I'm sorry, b squared plus a squared equals c squared. And then I can subtract b squared from c squared to get a squared, and I can subtract a squared from c squared to get b squared. Okay, so those are all your options of true statements. Find the one that is not true. Also, c is the longest. So it has to be at the end of the sum, and a squared number is always positive, or a squared value is always positive. All right, so here, number 3, consider the diagram. Count the side measures. So what that means is these little squares here, I need to count them to see how long they are to find the area of them. And according to these answers, it looks like I'm dealing with 8, 6, and 10. So this is 1, 2, 3, 4, 5, 6. So this is 6 squared, which is 36. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 squared, so this is 100. And this is 1, 2, 3, 4, 5, 6, 7, 8. 8 squared, so this is 64. So now I'm plugging in the a squared plus b squared equals c squared, and I'm mixing and matching them up. So it's 6 squared plus 8 squared equals 10 squared. It's 8 squared plus 6 squared equals 10 squared. 10 squared minus 6 squared equals 8 squared. And 10 squared minus 8 squared equals 6 squared. All right, it says triangle PQR is shown, and we want to determine these statements or determine the true statement, so one that is supported by the diagram. So when they give us questions like these, Pythagorean theorem questions, most of the time, and I want to say all of the time, but don't quote me on that, they're always going to label my right angle. So once they label my right angle, I can draw my arrow away from it, and this will be my longest side. So this will be C, and this can be A, and this can be B, okay? So QR is the side length, and I want to square it. QP is another side length, and I want to square it. And I'm going to add those to get the longest side, which is PR squared. Okay, so PR is the longest side, and sides must be squared. Okay, I can't just say side lengths. I have to square the side lengths. Well, side lengths or measures. Lengths/measures, pardon my sloppy handwriting. My side lengths or my side measures must be squared in order to apply them to the Pythagorean theorem and find their sum to get the longest side squared. So it says, according to the Pythagorean theorem, which of the following statements is supported by the diagram? It says the square of the length of RP plus the square of the length of QR. So let's find RP and QR. If I'm adding RP to QR, I'm adding my longest side to one of my short sides, and I don't want to do that, okay? So that's not going to give me what I need. So F is going to be wrong. G, it says the length of PQ, all right, let's look at PQ, that's B, plus the length of QR, okay, that's it, equals the length of RP. Okay, wait, they're not squaring these here. Remember, we said my side lengths must be squared. These are just straight up side lengths. Don't want those. That's wrong. All right, so I've narrowed it down to H and J. You determine which one is the best answer. Going on to page 206. All right, it says hold on, let me get focused here. Use the information to answer questions 5 through 7. A triangle is formed by joining the vertices of 3 squares shown. This is how we form our right triangle. For each statement, write T if the statement is true or F if it is false. Okay, so it says the area of the square with the side length X, that's over here, can be determined by finding the difference in the areas of the other 2 squares. So again, in order to determine the longest side, I'm going to come from my right angle and I'm going to draw an arrow. This is my hypotenuse, so this is the longest. Okay, and if I want to find any of the shorter ones, then I'm going to have to subtract something, and that involves a difference. Number 6, the length of side Z can be determined by adding the lengths of X and Y. Z can be subtracted or found by adding the lengths of X and Y. Remember, side lengths must be squared. I don't see a square there. Number 7, The relationship between the side lengths of the right triangle can be modeled using the equation x squared plus y squared equals z squared. Make sure you know where your longest side is. 8 and 9, it says use the information here to answer questions 8 and 9. Cody has a garden area in his yard in the shape of a right triangle. The diagram shows 2 patios that he has created using 1 foot by 1 foot square 1 foot by 1 foot pavers. Pavers are like bricks that you use to like lay out to make a solid like ground or whatever. So let's count these 1, 2, 3, 4, 5. So this is 5 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 squared. So this is 25, and this is 144. And whenever they give you a picture like this, just assume that you're going to have to figure out the other side here. Okay, so I traced it. It's not the best illustration, but whatever. So this side equals 5 squared plus 12 squared, and whatever that calculates to. So this is 25 plus 144 equals some number here, and that will be the area of this extra space here. So it says Cody wants to add a third patio along the hypotenuse. I put a box around hypotenuse because that's my longest side, and then I said, hint, calculate the hypotenuse. So he wants to put it along the hypotenuse of the right triangle. How could he use the areas of the patios already created to determine the number of pavers needed for the third patio? Obviously, that's just using the Pythagorean theorem. A squared plus b squared equals c squared. Number 9. How many pavers does Cody need to build the third patio? So each of these little tiny boxes here is a paver. Okay, so this is basically they're asking for the area of the square. What is the area of this missing square up here? And then that'll be your answer down here because each paver is 1 square foot. Okay, little tidbit there. All right, I hope this helps. Y'all have a good one. See you tomorrow. Turn this in and skyward as soon as you get done. Bye.